Hey folks, Quill18 here, and welcome to another Unity 3D tutorial. Today we're going to be looking at the incredibly complex and multifaceted idea of pathfinding in Unity 3D, and you're going to see that it's actually really easy to implement something that is totally free and works pretty well for a huge number of agents. So the very first thing we're going to do, of course, is we're going to start a new project. We're going to go new project. We're going to call this /sites/pathfinding tutorial. And while that is doing that, we are going to flip to our web browser and we're going to pull up this web page that went away called the A* Pathfinding project, because of course pathfinding is supported inside of Unity 3D if you have the free or the pro version. If you only have the free version, you do not have pathfinding built in, which is why you're going to go to Google and you're going to look up Unity 3D A* Pathfinding project, or you can go to aarongranberg.com/A*. There will be a link in the description block down below. And this thing is awesome. It does have a pro version that you can purchase, but you can also download the basic version for free, and it works really well. So now that you've downloaded this package, you can flip back over into Unity, and in fact you're going to have downloaded the package. You're going to have a zip file that contains a project file, a package file for Unity. You're going to double click on that and you're going to pull it in. And we're going to set that aside for just a minute, but you need this to run, and this thing is fantastic. I really quite like it. So while that is doing that, we are going to flip into Blender and create ourselves a nice little terrain to walk around in. I'm going to use the same sort of technique that I've used before to make some kind of basic mesh here. So inside of Blender, we are going to create a plane. And I'm going to go into edit mode by hitting tab. In fact, I forgot to set up my screencast keys. Start display. All right, good. So you can see what keys I'm hitting over here. And I'm going to take this right now. It is a 2x2 unit thing. Of course, this is roughly in kilometers, or in meters rather. So I'm going to, I don't know, I'm going to scale it up to maybe by 100. I have a huge map. And then what I'm going to do is over here on the left-hand side, I'm going to find subdivide. I'm going to click that. I'm going to subdivide into the maximum number of cuts, which I believe is 10. So I'm going to do that, and then I'm going to do it again. So we are going to have a 100 by 100 mesh in size, but also in terms of vertices. So we are still in edit mode, and what I'm going to do is I'm going to make sure, yeah, I'm in vertex selection. I'm going to hit C to open the cursor, and you can see there's a bit of a circle here, and if I click, I can start to paint vertices and select them. You can scale up your selection with your mouse wheel. Very easy peasy. I'm going to hop out of that, deselect everything, and what I'm going to do is I'm going to paint a basic map here. Make this a little bit bigger, and what I'm going to do is, I can't actually zoom out anymore. I'm going to go into top view, and let me grab this. So there's going to be sort of maybe a starting area over here, and there's going to be sort of another biggish area over here, another one over here. Here we'll make kind of an interesting kind of maybe a donut-y shape, and then it's going to be the final goal, and I'm just going to paint them all to connect them. Boom. So I've done this sort of thing before. It's a great way to lay out a quick and easy map. And what I've done in the past is I can then hit G to grab, a Z to just move in the Z axis, and then move it up and down and say drop it by, so we'll go -3, because our people in the game are generally about 2 meters tall is the general size for like a humanoid. So I thought, well, that's pretty good, but then I didn't like these sharp edges, so I'm actually going to undo that. And then over here, this is the proportional editing. I'm going to enable that, and then I'm going to do G, Z, -3, drop it by 3. But then the mouse wheel selects affects the size of the proportional editing. So then we can get some sort of nice, more smooth kind of edges. And I thought, oh, well, I like that quite a bit. I'm going to hit enter to lock that in. And I'm pretty happy with that. That looks like a pretty cool looking kind of map area for our people to wander around in. It should actually be pretty big, but that's fine because we're going to spawn a lot of units into it. So now that we've done this, oh, the last thing I'm going to do just to get it to look kind of nice is select all. I'm going to hit space. I'm going to go Smart UV Project just to give us a basic texture UV coordinate set. And hit OK. Good. We're going to save that. I'm going to go up to my sites. I called it Pathfinding Tutorial, Assets, and I'm going to call this Level Mesh. Boom. Save this Blender file, and then hop back into Unity. So our project should be in there, our A* Pathfinding should be there. It is currently just importing this model from Blender. It takes a minute. There we go. We've got our level mesh there. Everything is lovely and awesome. We are going to turn on Generate Colliders. so that we actually have some sort of like physics-based colliders that our things can stand and walk on. If we don't do that, it's just a visual model with no actual collision information whatsoever. And then I'm going to drop this into level. Boom. So we've got our level mesh, it's centered, and everything is lovely. There we go. Look at that. Looks great. So I think we had it oriented kind of this way with our start area maybe being roughly down over here. All right, so we have a level. That is fantastic. Now we need, well, two things we could do. We could start off by creating our person that will walk around, and you know what? I guess that would be fine. Now our person is going to be incredibly simple. We're just going to create an empty. This is going to be our unit that moves around, and inside this empty we're going to give it a model. And normally you would make a model in Blender. In this case, I'm going to just use a capsule shape and drop it inside of the unit. I'm going to make sure that the capsule is centered, and it is. The only thing is the unit, let me set it to, oh, I don't have my num lock on. Let's put that back. I'm going to set it to 0. I'm going to position it where I want the unit to start, which is up here. And now, you should be able to see. Why is it so high up? Oh! Because I didn't do the thing that I normally do. Let me save my scene. Let me go back into Blender. And I'm still in edit mode. I'm going to go to the right hand view, or the front view, I guess, by hitting 1. I'm going to just scroll over here, and what I'm going to do is I'm going to take everything and move it up by 3. There we go. That's what I want. That way my ground is at the 0 mark. It just, you don't have to do this. You could just, you know, I could move my character models down, but doing that will save me a lot of headaches because I know that the 0 point in my level is the normal ground. So there we go. So now the level appears to be higher up. And then you can see that my capsule actually intersects the ground because, of course, all of the Unity basic models that you can add with the Create Other, all of them have the center of the model is at their 0, 0, 0 point, their origin. So this capsule is 2 units tall, so if I want to have it sitting on the ground, I can just increase the position by 1. And again, this is the sort of recommended configuration. You have the actual unit as a empty, and then you have your model. In fact, we were going to rename this capsule as model. Okay. Ideally, again, you would go into Blender, you would make yourself a 3D, either a character, a mech, a tank, whatever you want these critters to look like, and then you would drop the model in there. But you put all your game logic and everything on the unit. Now, the one got you here with the Unity built-in objects. They come with their own colliders. So I'm actually going to take the collider off of the model. The model information is just the visual data that we want to use and absolutely nothing else. I realized the level would look a little bit better if we had a directional light put in there, so we've got some amount of shading going on. Alright, so we've got that, that's good, and now our unit, we need to get this thing to work. So our unit is going to have a character controller in it. If you don't know what character controllers do or how they work, make sure to check out my first person controller tutorial because we talk about that all over. So that's actually a component, it's a physics component, a character controller. And if I zoom in again here, so this is what controls your unit's movement and capability to sort of interact with the world. It's also its hitbox, and again, this hitbox is a capsule shape, which is an excellent shape for a character controller, but again, it is centered on the origin. So what we're going to want to do is go into the Y and just bring that up, and there we go. So it's just touching right on the surface. I think it might be a little more obvious too if we went to wireframe. Yeah, you can see there that it's really just lying on the surface very, very well, and everything should be groovy. If we hit play right now, nothing would happen. It would be a very boring world. Yeah, nothing exciting whatsoever. So, great, we've got that. Excellent. So we're going to turn this guy into a prefab. And I guess we can leave him here for now. That is fine. So let me get out of wireframe mode. We'll go to textured mode. So the next thing we want to do is actually set up our pathfinding, because our goal is to have this dude walk over here, right? So that's going to be our target. So what we need to do, and you can find this documentation on the A-Star Pathfinding project website. We create a new empty. We can call it whatever we want, but I'm going to call it our A-Star object, okay? This is the object responsible for generating all of our pathfinding. If you don't know what A-Star stands for, it's just a type of pathfinding algorithm. You can read up all about it, and in fact, I recommend that you do. So on this A-Star, what we can do is add a component, and you'll see when you have the pathfinding project included, there will be a pathfinding menu over here, and we want to add Pathfinder to our A-Star component. takes a second. Do you want to enable JavaScript support? If you're going to use JavaScript, you can hit yes here. It'll reorganize the folders for you so that they work better with JavaScript files. I'm going to say no because I work in C#. Then we have to add a graph. So graph is what contains the actual information for moving around in the game world. Most likely, in a fairly complex setting, you're actually going to probably want to use a nav mesh. And in the free version, I believe you have to construct this yourself in Blender and all that, and that's going to be just a little outside the scope of this particular tutorial. Instead, we're going to use a grid graph. Now, a grid just simply sets up a grid of points and then tries to detect like where which point is a valid walk area or not. You can actually have multiple grids, or multiple graphs rather, in the pathfinding world. We're just going to work with one in this particular scenario. So our grid, we can click on it to expand it. Apparently it's taking a second. My computer is freaking out. Can I not? There we go. Why did I have to hit the I? Oh, because I was in the renaming of it. All right. So we can expand our grid. Some of the formatting I find just a tiny bit off, but this plugin undergoes quite a bit of changes quite often. The two main things we need to set up here are the width and depth of, so like the width this way and the width this way, depth this way, of your grid, as well as the node size. So right now it's defaulting to a node size of 1, which is actually fairly tight, and for our world we don't need it to be quite that tight. The big thing is we want this graph to cover our entire zone. Now we know it's 200 by 200 unit because that's what we put together in Blender. So we want to end up with about that. I think we can probably, for our purposes, probably do a node size of about 5, and then that will mean a 40 by 40 area. And for some reason this keeps the, I don't know, the positioning is kind of weird, even with this anchor set to the middle. I'm not 100% sure what the right behavior here is to get it to work the way that I want it to. So I always have to reset the center after I change my graph. And then it doesn't always update here. If you go down to the bottom and you hit scan, then it'll rescan your level, and you can quite clearly see that it has correctly determined like kind of where you can walk and where you can't walk, what obstacles are. You could, if you check the documentation on the website, they've got a great tutorial in there that walks you through if you're like putting down blocks and things in the world, but we're going to keep it a little simpler here. Now, it has determined that based on certain settings, what settings? Well, it is determined that the slopes are not valid walk points. And why is that? Why can we not walk on the slope? Well, it's because of a combination of the max climb and the max slope settings. It is figured that our character is not going to be able to walk up these cliffs because they're too steep. If we made the world a little flatter, then it would be able to walk up and down. In fact, this is a tiny bit, no, not quite. And you can see the things are colored slightly differently. It's got red, blue, and kind of purplish because the graphs are kind of broken. So I could mess with these and probably have something that is walkable up and down, but I actually don't want it to. I'm quite happy with it not walking up the cliffs. If you've worked with the character controllers before, again in the first-person controller, you know that the character controller also has a slope limit, right? And so the A-Star controller pathfinding doesn't know what your character slope limit was. In fact, you could think of it in terms of different characters might have different slope limits. Tanks might not be able to climb up cliffs, whereas, you know, something bipedal might be able to do that quite a bit better. So what you want to do with your A-Star is try to figure out like a good number that might not actually match your actual character. And one of the things I like to do is actually set this as quite a bit more conservative than my characters. For example, yeah, you can see here it's actually got a line cutting through this little hill. It figures, oh, that's a valid walk through there. It's not too terribly steep. Well, I don't like that. Or rather, what's going to happen later is we're going to kind of smooth the path that you can walk, so that people are going to be cutting corners a little bit. So you want a little bit more, you want your character to actually be able to walk up some of the hills when it cuts corners, but be kind of conservative with the pathfinding. All in all, this is pretty good. The one thing that's going to happen is we're going to change the height testing here. So our graph is at the 0, 0, 0 point. It's right on the ground, and what the ray length does, the height testing does, it actually goes currently 100 units up and then ray casts down. That way, if you had all kinds of wild and crazy slopes, it would still generate valid walking paths all over. Well, I actually don't want it to render or figure out any pathfinding for the top area. That's just going to be memory it doesn't need to ever consider. So I'm going to change the ray length to something like 2. 2 is actually going to be too short for it to see uphill. So if I scan again, it should only capture the bottom bit, which is perfect because that's the only area I'm ever interested in doing any kind of pathfinding for at all. So we're a pretty good way there. There's lots of other variables we can mess around in here. I am not gonna bother. I'll leave it here. Oh, the max climb. I'm gonna change the max climb to a higher one. I'm gonna say like or quite low. I'm going to have it be very conservative to the steps that it generates. You can see it cleaned up a few edges, a few places where it thought, oh, you can step over this just fine. I took that away so that it won't do that as much. I'm not going to take that away in my character model, though, just here. Okay, so that is the, I'm going to just save that. That is the graph, which is awesome. So the next step is to make our little person actually walk places. And there's two things we're going to have to add to our component here to do that. First of all, our character unit is going to need, in pathfinding, it's going to need a seeker component. So the seeker is what actually generates, it actually talks to the graph and finds path based on certain destinations. And then we need a third script. Okay, so we've got our pathfinding script on A star, we've got the seeker script on unit, and then we need a third script on here, which is our own script, because pathfinding is really specific to whatever application you're currently working on there. So I'm going to call this, what am I going to call it? I'm going to call it AI Pather, something like that. Sure, it's a terrible name, but it'll work. All right, so we've created a script. And we'll double click on that, and it's just going to take a moment for it to load up. Let me move this over on the other window. Normally I write everything from scratch and really go with the flow, but in this particular case, because I'm trying to make this kind of a fast and easy tutorial, or fast anyway, I'm going to just load up my code in the other window so that I can step through it without making too many mistakes. Notepad++, and let me just swing it over here. A lot of what I'm going to do is going to be semi-based on some of the examples from the tutorial of the website itself. So if you've done that at all at any point, it's going to seem familiar to you. I've also used this before for a couple of projects. So I'm going to start off by ripping all this out. So our AI pather is going to need a few things. First of all, it's going to need to know where to go. Now, you can give it a coordinate. You could give it a sort of a vector 3 target position or something like that. Okay, that is totally fine. But what I actually prefer, especially with debugging and things, I like to actually just give it a transform called target. Okay, this is going to be a public, and then what I can do is in my scene editor here, I can create another empty. I can call this guy target, bring it to the 0 point, and then yeah, just put it right here. This is my goal, target, and then in my unit, it's got a public here for target. I just drag it in there. Because that way, when I'm testing, I can take this target, I can move it around, right? And try different combinations and see what works and what doesn't. I find it incredibly handy. So, we've got that. Now, I am still going to use a vector 3, but I'm going to make it a private here called, this will be target position. Just that way, no, let's not bother. It'll be fine. What are we going to do? We are going to create, in start, we are going to grab our seeker. Right? And in fact, we're going to store that because we'll probably want to reference it later. So seeker equals get component seeker. Okay? You might want to check to make sure that it actually grabbed it, but in our case, we know that it's there, so we're just going to trust it and everything's going to be fine. So in seeker has a command called start path. Okay? And we give it a, we tell it where we are now. So our own position, transformed up position, where we are now, where we want to go, which is going to be our target dot position, and then when it completes, and it's actually multi-thread. Well, you can turn it on so that it's multi-threaded. It'll run in the background. By default, I think it uses coroutines, but you can actually offload the task to a separate CPU, which is fan-freaking-tastic. So what we need to do is we have to give it a function to call when it actually finishes calculating the path, because we don't know otherwise, because this returns immediately. So we're going to create a function called onPathComplete, and then we actually have to have this exist. So, and I believe it has to be a public. You can test either way and see what happens on path complete. And we actually get an object called path. And we're going to call it P. All right, seeker start path. When it finishes calculating the path, it will call this and it will say, here's the path. And then what do we do with it? Well, by default, we don't have to do anything with it. We're going to see exactly what happens when we just do this. So let me flip back over. We have an error. Oh, type. This is very important. The type or namespace path cannot be found. Why? Well, we need to add another include over here. You need to say using pathfinding. Okay, it's a different namespace from the plugin using pathfinding, and now it will know what a path is. And that should clear that up. And if we hit play, path complete. All right, so it took 3 milliseconds to find the path, and you can see it drawn here. It's going to be a little hard to see, maybe a little bit better this way. No, it actually doesn't change the thickness of the gizmos whatsoever. Let me check my little preview window. That is hard to see on YouTube, isn't it? Oh, man. Almost what I need to do is like kind of turn off the grid. Like that. It's vaguely better. It's really hard to see, but there is a green line here going down here, following right over here, doing a little sharp corner. Don't worry about it. We're going to clean that up later. Comes around here, and again, it's, you know, it's kind of jagged, right? It's like that. Well, why is it jagged? It's because it's following the graph, right, which is mostly square. Now, there is a slight startup time on the program the first time, and you might think, well, it's taking a long time to do the pathfinding. But it's not. It actually goes incredibly quickly to find the path. The thing is, the grid itself has to regenerate every time. When you start the program the first time, it generates this grid, and that can take a while. Luckily, what you can do under save and load is you can have it generate the cache. It'll do a scan one more time, and then it's going to save this graph, and you can see the cache startup tells you the size of it as well. And now when you hit play, it's going to be like instantaneous. It's just going to go, it's going to do the pathfinding, 4 milliseconds to figure it out, and that's not shabby. That's not terribly shabby. So that's good. It doesn't actually move though, and because of the fact that it's so hard to see the green lines on the YouTube window that I can see, we're really not getting a whole lot of action until we get this guy to move. So let's go and do that. There it is. Oh my god, I just realized, my apologies, that everything was off the window. I feel terrible. How hard was it to see the code? Well, you saw some of it, but now at least you see all of it. I don't want to restart it because I'm just trying to do this in one shot very quickly. One take. Alright, so the big question is, what the hell is the path, right? What do we do with it? How do we work our way through it? That sort of thing. Well, first of all, we want to cache that. We want to path. That's for one. And a path is made up of a series of waypoints, okay? At each point in the graph, where is it? At each point in this sort of grid, right? Each one is a waypoint. It says, go here, go here, go here, go here, go here, go here, go here. It's just a series of coordinates, one after the other, after the other, after the other. And it's just in an array. So there's an index, so we need an index for that, and we're just going to call it, we're going to use the same names that they use in their tutorial, current waypoint, and we are going to start that off. When we get a path, we are going to first of all grab the path and save it. Oops. Come on, P. And then we are going to set the current waypoint to be equal to 0. Now, technically what we should do here is do an if not p.error, right? Because the path may have failed for some reason. It might not be reachable. And in fact, you can output that. You can do something like else debug.log p.error, right? If you want to know what's going on. So great, we have saved the path. That is fantastic. Now what would we want to do? Well, we want to move our guy around. We can do that in an update or a fixed update. Either way is perfectly fine. It partially depends on kind of how you're moving things around in physics and different things. A fixed update is probably a decent idea here. Like so. Now, our path normally would start with a null. So the first thing we want to do is, if path is equal to null, we have no path information, return. Right, we got nothing to do. Secondly, we want to see if our current waypoint is bigger than the amount of points that we have. And normally the way I would do this is actually run it once, let it go, and then find out there's an error at the end of it. But so if our current waypoint is bigger than or equal to path dot, so path gives us, path itself is not an array. It's got arrays in it. It's actually got two versions of it. it's got, I think, path and vector path. We want vector path because that's just an array, or rather a list of vectors. And we can get the size of it from count. So if the current waypoint is greater than or equal to the count, then, again, it's just return. We got nowhere to go. We've reached the end. So now we can move towards things. So how do we want to move towards things? Well, we know that the next point we're trying to go to is, in fact, let's do it. Let's do it a cheating way. If we go something like transform.position is equal to path, path.vectorPath for the current waypoint. We're just going to do this. This will not behave the way that we want. But let's just do that. We're just going to set ourselves to the next waypoint, and then I guess we can say current waypoint plus plus, right? So what should happen is we will very quickly teleport 60 times a second from point to point to point to point. Let's see what happens when we hit play. Brrrr. Again, like, we're very far away. Let me select the unit so you'll actually see the little gizmo move. And you'll see we will warp speed around there. Because our fixed update operates 60 times a second. So, and every time it runs, we're just moving one coordinate. So we are at the rate of 60 grid squares per second. We are going all the way to the end. Clearly, things are working pretty well. So, okay, we don't want to actually teleport from grid to grid to grid. We want to move. And we want to move at a certain speed. So let's give ourselves some sort of float with a speed. 10, I think, is a kind of a reasonable-ish kind of speed to do different things. We'll see how it goes. So we don't want to grab the direction or the next vector directly. We want to know what direction we want to move in, right? So we want to say something like vector 3 direction is equal to the vector path minus our current position. Right? That is the direction we need to move in. And that's the raw direction, which is good, but we want to scale this based on the speed. And what we need to do is actually turn this into a normalized kind of vector, because right now, this, depending on how far apart your points might be, right, this might return, if you're very close to the next grid point, it might return 0.1, and if you're very far to the next grid point, it could return 10 or 50, or depending on what side your grid is. So what we want to do is, the difference of these two is actually still going to be a vector. We want to take that and normalize it. This guarantees that the vector is a length of 1. Total length of the vector is 1. So then we can take this and multiply it by our speed. But then we also need to multiply it by the time since the last frame. Okay, and in this case, since we are in a fixed update, we actually want to do time.fixed delta time. It's slightly different. So this will move us up. So this will guarantee that the distance is equal to 1. This will multiply it by our speed, which at this point gets us a vector of length 10 in the correct direction. But again, we don't want to move 10 every frame. We only want to move a fraction of our speed based on how much time is spent since the last update. So that is what we want, and we have a character controller on our object, in which we should cache. So we want to grab our character controller. Again, if a lot of these concepts don't seem familiar to you, if you don't really know what's going on, then check out the first-person controller tutorial. It should resolve a lot of those issues, because we deal with a lot of these concepts in there, like what a character controller is and why it's important, and how we move a character controller around. We are simply going to use move character controller dot move. Actually, we want to use simple move, which means we don't actually need to do the fixed delta time thing, because simple move just wants a speed, and it will figure out the delta time thing on its own. It's quite happy with that. Now, the next thing we have to do, and this will get us started. The problem is, right now, every frame we're also moving the waypoint forward. Well, we don't want to move the waypoint forward every frame. We want to move it up. We only want to change waypoint when we get to the current one. If we have reached the waypoint we are currently walking towards, then skip to the next waypoint. Now, we don't want to wait until we're literally 100% on top of it, because what's going to happen is we're going to overshoot it a little, and then wiggle back, and then wiggle back, and wiggle back, and you just wibble wobble. Very rarely will you land exactly at the coordinates of the next waypoint. So you need some sort of margin for error. So what we need to do is we need to know the difference, okay, so the distance, the difference, vector3.distance between our current position and the position of the next point that we're traveling to, right? The distance between the two of these, if it is less than some distance, we are moving at a speed of 10, our graph distance is 5, we could probably do something like less than 1 is probably fine. You know what, you probably do less than 2. And in fact, what you actually want to do is put this in some sort of float that says waypoint distance, maybe max waypoint distance is equal to 2. So if it's under that, you know, some damn thing, whatever you want to call it, then we increment the current waypoint. Let's give this a try, see how badly we've screwed things up. And hit play. God, it actually seems to be working. Look at us. And I don't know if you noticed here, but just before it actually got to the corner, it started moving to the next point because we reached that minimum distance, so it started to turn at that point. And we seem to be making the trip pretty well. I'm actually not super keen on the speed. Let's double the speed. And I think I'm going to feel a little bit better about that. Yeah, all right, so that's not bad. But again, you know, it's very jerky because it's following these grid lines perfectly. And depending on the kind of game you're making, that might be good. But maybe you don't want that. So there's two ways that you can really sort of fine-tune that aspect of it. What you want to do is you want to add a path modifier to these guys. And this is something that happens automatically. The seeker, which is responsible for finding the path, will check to see if you have, under pathfinding modifiers, if you have any pathfinding modifiers applied to your object, and it will apply those. For example, one of the simplest is simply simple smooth. There's a few different possibilities here for how to smooth it. The defaults are pretty darn good. You know, depending on how big your graph is, you might, you know, tweak the number of iterations and things like that. But the default often is pretty nice. We'll see what happens when we hit play here. You'll actually see that the path is slightly round. In fact, it's not quite round enough for me. But it is slightly rounded. It's actually not enough to make a difference because we're already sort of cutting the corners a tiny bit. But depending on how you are designing it. Now, again, the grid won't change. But you can see the path here is just rounding just a little bit. You don't want to do too aggressive with it because what Simple Smooth can do is it can cause the corners to be cut so much that that you actually like plow into the corner of a wall or something like that, where normally it would have avoided it. And that's the other thing. In A star, when you're setting up your information over here, you can specify the width of your collision, because if you've got quite a big model, a big fat model, you have to tell the grid that your model is going to be a fair bit bigger, because then what it'll do, it gives you more of a margin for error around walls and things like that. So, you know, you tweak these numbers to get them to work kind of the way that you're looking for. So Simple Smooth is pretty good for a lot of cases. Give it a try and you'll see. But for our particular case, what works out a lot better, let me remove this component, is the funnel. Okay, the funnel modifier. And what does funnel do? Well, right now, this guy's going to come here and then go to this point and then pathfind to like this one and this one and this one and this one and so on and so forth. Well, what the funnel does, my clip distance wasn't right for me to zoom in. What the funnel does is it recognizes that, hey, if I'm here, I can actually go in a straight line directly to this point. I don't have to wiggle here and then move up that way or anything like that. And on this particular map, I found that the funnel effect was exactly what I wanted to make it look perfect. So let's give it a try with the funnel effect and see what happens. There you go, the green line, and you can see how he moves. The green line cuts right through there. In fact, it's using these midpoints and going straight through and coming up with a much more appropriate route for this kind of map. Again, it's going to depend entirely on what kind of game you're doing, what your map looks like, all kinds of things, how much you can afford to cut corners, little things like that. One thing to notice, this guy won't actually make it. The target is actually like right here. He doesn't actually reach the target because when he gets within 2 units, he stops. So if that is not acceptable to you, you'll have to tweak the function a little bit more. But in practice, that should be fine, and you don't actually, again, because you're going to have that wibble wobble problem. So you actually want them, whatever they're going to do at their goal, to be able to have some margin for error about arriving there. So that is pretty good. All right, I'm happy with that. Now, what can we do to make it even more awesome? Well, this unit is a prefab. I just applied it to lock that all in, so I can actually get rid of it. So I like that. Now, let's have lots of these. Actually, I guess I could undo the delete. Did it keep all the associations? Yes. All right. So let me grab this and duplicate and duplicate and duplicate and duplicate and duplicate and duplicate and duplicate, and then grab all these and duplicate them some more and duplicate them some more and duplicate them some more and more and more and more and more and more and more. All right, that's pretty good. We got a huge amount of object. Now, if I hit play, everything will still work. Frame rate will be a little bit worse than before. And apparently I'm lying because nothing is happening. What? Oh, there we go. I have no idea what I did or didn't do, but it's working. Now, it's working pretty well. Now, in some games, maybe you don't want them bunched up this much. They're all following one path. Like, it's pretty obvious, right? They're all following exactly the same path. Was that appropriate or not? Again, it depends on what kind of game you're making. If it's not appropriate, hey, I've got another modifier for you. Add component, pathfinding, modifier, alternative path. What alternative path does is it adds a penalty on the path when someone has chosen a path. All points on that path, they mark as having a slightly higher penalty, and it will encourage other units to choose alternate paths. You can choose, what the penalty is and all kinds of things. Now, one thing is, depending on the order of these modifiers, they don't always work. In fact, right now it says modifier priorities, errors in modifiers. If I tried to hit play right now, it wouldn't work. The reason is, can I not, pop this open? The reason is alternative path actually has to come first, even though the priority is there. What happens if I change it to 3? Does that fix it? Yeah. The alternative path has to be the highest thing. In fact, it has to be before the input here. Normally what you do before you add these modifiers, you would expand this. It seems like kind of a bug that I can't expand that modifier beforehand. Alternative path has to come first. If I drop it down, there's going to be an error because the output's not correct. So you put the alternative path first in the list, and now if we hit play, there should be a little bit of a splitting up in the routes. And you can see a little bit, there's a bit of a split there, depending on the map, and you can see some people are choosing one, some people are choosing another. Depending on the map and the number of nodes and how it's designed, there's enough of a cost to encourage people to go somewhere else. Let's turn up the penalty a lot. Let's turn it to, I don't know, 10,000, just to see what it does. Different tunings. I didn't need to do that in my last map, but in this one, I was hoping to get people to go around the donut. That's my goal, is to have them go around the donut here, because they were doing that in the other one. It's probably something else I have to tweak to encourage them to do that. Actually, what I was doing in the other one is I was actually having the units spawn from a spawner. And if we go back to it, I'll do that, because what the heck. You guys have pretty much seen everything at this point. RTS TD. Sort of Temo. I'm not actually making a real-time strategy tower defense game. It was just the name. Where's my level 1 scene? Right? Oh, and I applied a texture to it. So what I've got here is I've got a unit spawner here, and all it does is it just instantiates the units. And the goal over here, which I've actually set as a sphere this time, it's got a collision box on it, and then when one of the units hits it, it deletes the unit. So they're going to be constantly spawning down here and constantly being eaten over here. And then I set the spawn rate really quite high. And there you can see I feel that the alternate path seems to work better this way. And see they're going different areas around here. One of them has chosen to go around the far side of the donut here. So that's it. It's the sheer number of traffic, sheer amount of traffic. And you can see even with recording on my computer, the frame rate is still incredible here. And that's without like tweaking lots and lots of things. And a fair number of draw calls, and with all the debugging information on the screen. It has dropped now, although it's going to stabilize now because this is the most number of units you're possibly going to have because they're all hitting over here. That's not bad considering the number of things that are out there, and with no optimization and a relatively complex mesh, not much caching. Like there's so many things you can do to optimize it. And again, if you just use a nav mesh, it'll be much more optimal than a grid. But there you have it, folks. I will put the files down below so you can test this out yourself and see how it works. Actually, I'll put the files for this one on because I don't know, looks a heck of a lot fancier, right? I think it does. I think this is the one that people are going to want to see. There you have it. So I hope this is useful. If you have any questions, please leave a note down below. And as always, if you haven't subscribed, please do so. Like, comment, share, do all that stuff because it really helps, because I think these tutorials are awesome and I would love more people to see them. So see you next time, folks. Bye-bye.